Good morning, Year 9s. Today is the 9th of April, 2020, Thursday. Hopefully your first week back has not been too challenging. So yes, today we're going to continue with sets and Venn diagrams. So this will be lesson 4 of 4 for this week. And we are going to be looking at questions 1 to 6. Now, as I said in the previous videos, a lot of the work we do from a book, obviously the answers are in the back of the book. So I will be supplementing your work by giving you questions from different sources so that I can get a proper understanding of how much you've understood this topic and where you might need further additional help. So as always, if you need me to explain things further, or if you're struggling, please drop me a message and I'll respond to you as soon as I can. Or as I said before, I can arrange a private Zoom session with you to explain things to you in more detail. Okay, moving forward to question 1. So the universal set is all the positive integers less than 12. So remember, the integers are the counting numbers which are not negative. So set A has the elements 2, 4, 6, 8, 10, and set B has the elements 4, 5, 6, 7, 8. And it tells us, show this information on a Venn diagram, and then list the intersection of A and B, and find the number of elements in the union of A and B, intersection, sorry. And does A and B, is it the same as A intersect B? Is it the same as B intersect A? And then it tells you to list. Now you've got to be careful here. There's the little comma on top, which is basically saying the opposite. So list the members which are not in the intersection of A and B. And the final part of the question is A intersect B a subset of set A? And so if we quickly just go through the solutions. The first one, so your universal set should look like this. So you got your rectangle, you got your set A, set B. Here in the intersect 4, 6, and 8. So they're the elements that are both elements, members of A and B. And then 1, 3, 9, and 11 are the elements from the universal set which are not members of A or B. Part B, list A intersect B, so that's the 4, 6, 8. So that's the 3 elements here, and there's 3 of them. Part C, does A intersect B? Is it the same as B intersect A? The answer is yes, because they both have 3 of each. D is list A intersect B, but as I said, remember the little comma sign up here, or the apostrophe, sorry, is basically, think of it, the not, is the opposite. So that's basically all the elements but are not in the intersection. So that's your 1, 3, 2, 10, 9, 5, 7, 11. And part E, so the question to part E, is A intersect B a subset of A? And the answer is yes. Okay. Moving on, you have the second question, which is in the universal set, all positive integers less than 12. Set E has the members 1, 2, 3, 4, and set F has the members 5, 6, 7, 8. So again, it asks you to show this information on a Venn diagram. Then it's asking you to list E intersect F, so which 2 elements are common. And if E intersect F is an empty set, this symbol is for an empty set, what can you say about the sets E and F? So again, going through this question, we can say that here's our universal set with both of the elements combined all together. Set E and F don't have anything in common, so there's no overlap between the two. So set E, it has elements 1, 2, 3, and 4, and set F has elements 5, 6, 7, 8. And obviously 10, 9, 11 are outside because they don't belong in set E or F. This is an empty set. So again, as you can show this symbol or with two empty brackets. Sorry, this brackets with nothing inside it. And then we can say these laps don't overlap. There's a disjoint between these two sets. Okay. Question 3, R is a set of roses in a flower shop and W is a set of white flowers in the same shop. Show this information on a Venn diagram. Describe the sets R intersect W in words. And if W is an empty set, what can you say? So looking again at the solutions, here's a universal set. And you've got the red flowers, the roses, and the white flowers. The white roses, which shows us is the white roses in a shop, and there are no white roses in the shop. So it says show this information. So here's the pictorial representation of this information on a Venn diagram. And it doesn't tell us the numbers, so we can't put anything in there numerical. All we can say is here's a set of red, here's a set of white. And if it asks us to describe, well, because this is empty, we say there's no intersection. There's no commonality, so it's empty. Describe the R set B in words. There are no white roses in the shop. And there are no, so white roses in the shop. This describes this set, and C, there are no white roses in the shop. Moving on to question 4. On the Venn diagram, the universal set is ice creams in Marco's restaurant. C has the elements ice creams containing chocolate, and N is the ice creams containing nuts. If a number of chocolates in set A is 53 and set N of the nuts has 36, so there's 53 chocolate ice creams and 36 ice creams and nuts. And remember, some of them can be chocolate and nuts, not just chocolate, but or not just nuts, can have chocolate and nuts. So it tells us to copy and complete Venn diagram. So here's the Venn diagram. So it tells us there's 67 altogether, and 21 has both chocolate and nuts. This is what we can tell from the Venn diagram. So how many ice creams contain chocolate but no nuts? So again, if we look at the solution provided to us in our book, so that's completed. So there's 32, 15, as I said, 67 altogether. How many ice creams contain chocolate but no nuts? So that's part B, and that's 32. So if you wonder, okay, where did these numbers come from? So we know there's 67 altogether. So 21 is common to both. So from there, we can say that, okay, what two numbers here, all of these need to add up to 67. So by using a bit of, we can get those solutions. And then how many ice creams contain chocolate or nuts but not both? And that's 47. And part D, how many ice creams are in the restaurant? And in total, that gives us 135. So universal set, sorry, it's not 67, it's saying there's ice cream that isn't chocolate or doesn't contain nuts. So that's how we get the 135 from. Question 5 and 6 is approximately the same. Again, try to do the questions yourself. And if there's anything, and you check your answers, if you got it wrong, have a look at it, redo it. And if you're stuck, let me know. However, I will ask you now, it's Thursday, I'm going to ask you to do a small piece of homework. So this is due on Sunday, and it's still on Venn diagrams, but like I said, this will be from a different source. It's got the explanations here and an example with the solutions to that example question. So your two questions for today is draw a Venn diagram to show each of the following, write their elements in the appropriate region. So universal set, you've got red, yellow, blue, green. Set A is blue and red. So that's one part. So that's question part one of question one, part two, part three, and question two. Illustrate each of the following on a Venn diagram. So again, you've got the universal set, you've got set A's and B. So again, show this information. Let me make this a bit bigger for you, so you can clearly see it. So question 1 and 2 is homework and it's due for Sunday. If you're having any problems, again, like I said, let me know. Just try your best and we'll catch up again on Sunday, which will be the 12th of April, and we will look at the union of sets. Anyway, guys, hope you have a good weekend, and first week back has been a success. If you have any suggestions or feedback, please let me know.